Let's resume section 10.3 with polar curves. The graph of a polar equation r equals f of theta, or more generally, capital F of r comma theta equals 0, consists of all points capital P that have at least one polar representation r theta whose coordinates satisfy the equation. So what curve, example 4, what curve is represented by the polar equation r equals 2? Well, we want all points such that r equals 2. We're not given any restriction on theta. So in terms of an xy representation, we would have the circle of radius 2. We want all possible values of theta, and we want r to equal 2. So we have the circle centered at the origin, of radius 2. Example 5. Sketch the polar curve theta equals 1. Here we're given a restriction on theta, but no restrictions on r. So the radius can be anything, but theta has to be 1 or something equivalent to 1. Well, if we're talking about 1 radian, that would be a little more than pi over 3, so we'd still be in the first quadrant. It's less than pi over 2. So theta equal to 1. Would be the line passing through the origin. That makes an angle of 1 radian with the polar axis. Okay. Let's try something a little harder. Example 6, part A. Sketch the curve with polar equation r equals 2 cosine theta. If we want to sketch this curve, okay, we want to, well, let's start this one by plotting points. So let's choose values of theta and figure out what r would equal. So if theta is equal to 0, cosine of 0 is 1, so radius of 2. So we can plot the point 0, 2. The point 2, 0. So we have 0 angle made with the polar axis and a radius of 2. Okay. Then if theta is pi over 6, cosine of pi over 6 is square root of 3 over 2 times 2 is just root 3. So when theta is pi over 6, we have a distance of root 3, so that's less than 2. So we can plot the angle pi over 6 root 3. If theta is pi over 4, cosine of pi over 4, square root of 2 over 2 times 2 will leave us just root 2. So when theta is pi over 4, we're left with square root of 2. Let's try pi over 3. If theta is pi over 3, cosine of pi over 3 is 1/2 times 2 is 1. So at pi over 3, we will have the point 1. We will have a radius of 1. Yeah, my pen is not cooperating, guys. There we go. Let's choose a couple more values of theta and r to see what's going on. If theta is pi over 2, cosine of pi over 2 is 0, so the radius is 0. So we get the point on the origin. If we increase, we use 2 pi over 3, we will get a value of -1, or a radius of -1. That'll actually give us a point in the 4th quadrant. I don't know why my pen's acting up today. If theta is 3 pi over 4, we will get a radius of -√2, just slightly more than 1, and along the line pi over 4. And of course, 3 pi over 4 with a radius of -√2 actually gives us a radius of √2 in the 4th quadrant, making an angle of pi over 4 with the positive x-axis. We use 5 pi over 6, we get a radius of -√3. If I plugged in pi, I would get back to a radius of -2, which the point -2 comma pi is the same thing as the point 0, 2, so I'm back to where I began. So if I connect these, I'll notice what I end up with is a circle of radius 1 shifted from the origin to be centered at the point 1, 0. Part B, find a Cartesian equation for this curve. So we could either take a look at our curve and write the Cartesian equation, remembering rules from college algebra, or we could do it algebraically. So we have r equals 2 cosine theta. For our equation. So we know that x is supposed to equal r cosine theta, or in this case, cosine theta is equal to x divided by r. So our original equation, r equals 2 cosine theta, can become r equals 2 times the quantity, x over r. Multiplying across by r, I get r squared equals 2x. But r is the square root of x squared plus y squared, and root. So r squared would be that quantity squared. That must equal 2x. So now we have x squared plus y squared equals 2x. Moving the 2x to the left-hand side, I get x squared minus 2x plus y squared equals 0. Now completing the square, I will get x squared minus 2x, take the -2, divide it by 2, and square it to get 1. So I need to add 1 to complete the square. And of course, whatever I do to the left, I have to do to the right. So the right-hand side will become 1 as well. So now I have x squared minus 2x plus 1 plus y squared equals 1. Completing the square in the first term, we get x minus 1, quantity squared, plus y squared equals 1. And so we have found a Cartesian equation for our curve.